हेलो जी। हेलो
हेलो
हेलो जी। बोर्ड नजर आ रहा है? बोर्ड नजर आ रहा है भाई?
यस सर।
चलो ठीक है। गुड, वेरी नाइस। I am also recording the, you see, I am recording the lecture also, and students can also later on watch it at their own leisure time. Okay, today's lecture is on circular motion for NEET students, for NEET exam, and I will start with application techniques. Right? Okay. Number one application. See, the important point in circular motion is that when a body or a particle moves in a circle or in a part of a circle, maybe in a part of a circle, you must know there is a force towards the center, and that force is mv square by r. Radius of r is the radius of the circle and v is the speed, or that force is equal to m or omega square. This force is remember that this force is a requirement towards the center. It's a requirement. If you want a particle to move in a circle, you need to provide this force towards the center. I mean, this force must be provided by certain agents. This is a requirement. Similarly, if a particle moves in a circular arc, it will not move in a circular arc unless you provide towards the center of the circular arc, and that force is mv square by r, or m r omega square. But I repeat again, this force is a requirement. It must be provided by the real agents. Some real agent must provide this force for a particle to move in a circle of radius r, whose mass is m and whose speed is v, or whose radius of the arc is r and whose angular velocity is omega. It is very important. Suppose I have this equation, F is equal to ma is the base equation. This F on the left side is actually the agents, the real agents that you have to search for. Sometimes you may have to search for these real agents. Who are these real agents which provide force? And this A is the acceleration. Of course, this is the net force. When F is equal to ma, this F is always the net force. And this A is always the net acceleration. And here I want to mention that in order to find the net force, you may have to have vector sum of the forces acting on the object. Net means you have to have the vector sum. But obviously, if there's a particle and this force is, suppose F1, this force is F2, then vector sum is F1 minus F2. There's no problem because the two forces are opposite. If you have a particle and forces this F1 and again downward forces F2, then total force on the object is F1 plus F2. There's no problem. You just add the two forces up, you just subtract the two forces. But the point is, when suppose a particle is here and there are two forces like F1 and F2 here, like this, then you have to be very smart. You have to find the vector addition rule. You have to find the total resultant force, and that resultant force is a that by vector addition. So that you have to be very careful. Suppose you have a force that is F1 on this and F2 like this, and you have to find the net force. Net force is simply root of F1 square plus F2 square. So when I say F is equal to ma, this formula seems to be quite simple, but this F is net force. Sometimes you may have to find this net force by addition of forces through vectors. And this m is mass, no problem with mass will be given, and this a is net acceleration. It is very, very important to understand this equation. F means not a single force on an object, it means the resultant of all the forces acting on the object. Sometimes there's a single force and then there's no problem, you have to mention only that force. But sometimes there are many forces on an object. In that case, you have to find the vector sum, right? You have to be very careful about it. Okay, let me go to now these examples of this circular motion. See, number one example. Suppose there is a fixed stand here and a pendulum is oscillating like this, and here velocity is v. Here it is, the point of suspension is O. The particle is oscillating. Here the particle is oscillating in a circular arc, right? What is the radius of that circular arc? L, right? If it is speed is v and radius of the circular arc is L, how much force you need in this direction? M v square by R. This mv square by r has been provided so that the particle moves in a circle of radius L. If this force would not have been provided, then the particle would move in a straight line. But what are the real agents? Listen to me. Which are the real agents which provide this force? That is the point. कौन से agents है जो इस string को ये force provide करते हैं? So that I will write an equation and you will try to understand that equation.
Tension.
Good. So what is important you see here, listen my words, we need to identify the agents. We need to identify the agents which provide this force. Now this force has been provided. We have to just identify the agents. Now look at this. Look at this. This mass. Look at this. This is mg is downwards. And this tension is upwards. Tension always pulls the object. Now I am going to write an equation for this situation. You just concentrate and try to understand how I write it.
Yes, sir.
You have an equation F is equal to ma. Basically तो यही equation है.
Yes, sir.
मगर ये left side का जो F है ना ये agents है. Right side का effect है. जरा agents देख लो. See the agents and find the resultant.
T minus mg.
Good. T minus mg are the resultant of the agents. So you must know what this F is. This F is the resultant of the forces. Magar real actual agents is equal to ma. That is the effect. That is mv square by r. Right? R is L here. Don't write on the board. Why you write on the board? It is very bad thing. So, what is tension here? That's mg plus mv square by L. That is the answer for the tension. If you are asked to find the tension of an oscillating pendulum when it is at the mean position, you find the answer here and you write the right equation like this. Okay, this is example number one. Now let me go to the example number second. Here it is half, I mean, half sphere. Half, it is a
Yes, sir.
half sphere, and the object is here at the top. It falls off, and here, when it reaches here, it loses the contact with the,
Hemisphere.
yes, it loses contact with the sphere. Oh, sorry, पूरा खत्म हो गया ये. Okay, let me draw again. फ्री हैंड से थोड़ा ड्रॉ करना थोड़ा मुश्किल हो जाता है. So the object is on the top, and it falls and falls and falls and reaches here, and here it loses
Contact.
the contact and it drops down. The question is, at which position is it loses contact with the sphere?
From base or from top?
Yes.
सर ये पोजीशन कहाँ से, टॉप से या बॉटम
बॉटम
से?
से. हाँ, ये आपने अच्छा क्वेश्चन पूछा. गुड, बहुत अच्छा क्वेश्चन पूछा. अगर टॉप से मिलेगा पोजीशन तो बॉटम से भी मिलेगा, उसमें क्या प्रॉब्लम.
यस सर. हाँ.
चलो एच, हमें ये एच निकालना है. फ्रॉम द टॉप पोजीशन, एट विच पोजीशन इट विल लूज द कंटैक्ट फ्रॉम द सरफेस. पहले मैं आपको एक इंफॉर्मेशन देना चाहता हूं. When a body loses contact with the surface, you see, and remember it for all times to come, when a body loses contact with the surface,
Normal reaction 0.
yes, when a body loses contact with the surface, the normal reaction is 0. That's very important. And normal reaction is in this direction, normal to the surface. Okay, here mg is downwards. Please don't make marks on the board. Mg is downwards, weight, it always acts down. Let me suppose this is theta. If this is h and the remaining distance is r minus h, good. And look at this object here. Here it moves in a circle of radius r.
Yes sir.
Here it just moves in a circle of radius r. If this is theta, this is also theta. What is the component of the force in this direction?
mg cos theta.
Mg cos theta. Mg
Cos theta.
cos theta. When it moves in a circle with here the speed is v, and that, you know what is this, that v speed? That is root of 2gh, because it falls how much distance from the from certain height, h. So what should be its velocity?
Under root of 2gh.
Obviously, because falling height determines the velocity, not how much distance it falls, how much height it falls, right? This
Yes.
falls only height h, so we write v is equal to root of 2gh. Anyway, how much force is needed toward the center to move it in a circle?
mv square.
F is equal to ma. How much? Who are the agents? Who are the agents?
mg cos theta and normal reaction.
Mg cos theta minus n, but there is no normal reaction.
No normal reaction.
Because lose contact. So here I will write mg cos theta minus n is equal to, and
mv square by r.
these are the agents which provide what? What do they provide?
Necessary centripetal force.
Necessary centripetal force. Good. You are understanding. mv square by r. Please mark it well. The agents provide the centripetal force. On the left side, you just sum up the agents. But summing up the agents is very simple. Sometimes the agents are in the same direction, add them up. Sometimes the agents are opposite direction, then subtract them. This one of the agent is 0 here, right? So
Yes.
this R is capital R. Of course, this from here to here is capital R. So mg cos theta is equal to mv square by r. M gets cancelled, and it is g cos theta is equal to v square by r. But we are interested in this h, right? Can anybody tell me what is this cos theta here from this triangle? This one.
R minus h divided by r.
Cos theta base, that is r minus h.
Divided by r.
Hypotenuse, that is r. ठीक?
Yes sir.
Shabash. Now put this cos theta here. Let me see what happens, right? Let me see what happens. So G cos theta is R minus
R by
H by R is equal to, what was on the right side?
mv r v square by r
V square by
r
R. What V square was 2GH
2gh by r.
by R gets cancelled. G gets finishes off.
Yes.
R minus H is equal to 2H. ठीक? R is equal to 3H.
H is equal to r by 3.
H is equal to R by 3. Do you understand this question?
Yes.
And how much from the ground?
Mm,
How much from the ground?
2r by 3.
Yes. If it is H here it is remaining distance. There's R minus H. There's R minus R by 3. That is 2R by 3. That is the answer.
Yes.
Good, very nice. Now let me go to the example third. Do you understand these things?
Yes, sir.
Very nice. Third. Now let me go to the C. If angular velocity, that is a particle moves, let it go anywhere it likes to go, but it moves in an arc here, in an arc here, arc here, arc here, arc here, right? It moves in a very arbitrary way. So what we have to find? Look at this, what I am asking to find. Suppose alpha angular acceleration is 2 radian per second square, and initial angular velocity is equal to 0. Radius of the arc at any point, maybe here, maybe here, maybe here, that is 1 meter. Question is, what is the net acceleration after 2 seconds? This is our question. A particle moves in an arbitrary way.
Yes.
Angular acceleration is this. It is initial angular velocity is 0. Radius of the path at that point is 1 meter. I mean, possibly it is moving like this here, or यहाँ जो radius path का होगा, इस path का जो angular path या इसको कहेंगे arc का जो radius होगा, that is suppose 1 meter. तो हमें यहाँ पर इसका acceleration निकालना है. तो इसका acceleration क्या क्या हो सकता है? Tangential हो सकता है, right?
Yes.
Centripetal हो सकता है.
Centripetal.
अगर दोनों हमें मिल गए तो
Net.
तो निकाल सकते हैं ना net?
Yes, sir.
Good, that's right. That's right. Just watch it out how I will do it. Let me find angular velocity after 2 seconds. Angular velocity is equal to, after 2 seconds, equal to initial angular velocity plus angular acceleration into time. You know where from I get this equation?
Yes.
I get this equation V is equal to V0 plus AT.
Yes.
Counter equation in angular motion is this. It is velocity after some time, it's initial velocity plus acceleration into time. It is final angular velocity, initial angular velocity, angular acceleration into time. But here condition is what? Acceleration is
Uniform.
constant. Good. And here what should be the condition? Alpha is
Constant.
constant. If acceleration is not constant here, this is not the equation to be used.
Yes.
If alpha is not constant here, this is not the equation to be used. But fortunately, alpha is constant here. So we can use this equation. So what is omega after 2 seconds? That is 0 plus alpha, that is 2 into 2 seconds, that is 4 radians per second. Is that right?
Yes.
Good. Now, I want to find the acceleration now directly. Now see what I will do. A particle is here, let me suppose. What is this tangential acceleration? Do you remember tangential acceleration is alpha r? No. If you have attended my lectures, then I have derived this equation. Tangential acceleration is alpha r, and centripetal acceleration towards the center of the circle, that is v square by r,
Yes, sir.
or r omega square. वो भूल गए? v square by r is equal to r omega whole square by r, that is r omega square. These things I have discussed and derived. You just watch all my lectures many a times so that you can understand everything.
Yes.
Okay. Now this alpha is 2, r is 1, and it is 2. What about this? R is 1 and omega is 4, that is 16, is 16, right?
Yes.
And net acceleration is equal to root of
Square root of 2 square.
at square plus ac square, centripetal acceleration. That is root of 4 plus 256, and it is 260. Answer. You understand how I did it?
Yes.
Just concentrate and you watch all my lectures which I have delivered earlier. You can understand things in an easy way. But my take was a little different here. I put alpha is equal to 2, right? I will put alpha is equal to 2t, and omega I is again 0. Radius is again 1 meter. Again, I will ask you to find acceleration at t is equal to 2 seconds. Same question I'm asking, but I have made this a little complicated. Here I am not putting alpha as constant. Here I am putting alpha as a function of time. Here I want to know how you are going to find the omega, because you no longer will use omega is equal to omega 0 plus alpha t. Yeah, omega initial. This equation is no longer valid. So my net acceleration, for net acceleration, I had to find tangential acceleration and centripetal acceleration. Centripetal is perpendicular to this velocity vector. Here it is r omega square. Here it is alpha omega. Sorry, alpha r. Magar, the point is, I want to know alpha, that is given. I want to know this omega, that is not given. So what should I do? Now see, I will do something. Alpha is equal to 2t. Here, as you know, alpha is not constant, therefore you can't use this equation. So while you can't use these Newtonian equations, these simple equations, you have to go to calculus. So calculus tells us that alpha is equal to d omega by dt is equal to 2t. d omega is equal to 2t and dt will go here. If you integrate like this, it is omega is equal to, क्योंकि initial omega तो 0 है, so limit दोगे तो 0 to omega देंगे आप, 0 to 2, because in 2 seconds, तो 2 बाहर, t का integration क्या है, t square by 2, under what limits, 0 to 2, ये 2 cancel हो गया है, तो 4 minus 0, 4, right? So I got omega. What is alpha? 2t. But now what's alpha here? After 2 seconds. So what's 80?
4.
That's alpha r. Alpha is 2t and you have to find the acceleration after 2 seconds. Therefore, you have to find alpha after 2 seconds. That will be alpha is 4. R is 1. That is 4. And what is a? Okay, a centripetal acceleration or omega square. What is the r? 1. And what is omega square? Yes, 16. No. What is a net?
Yes, sir.
Root of
Under root of 4
at square plus ac square. That is root of
AC square.
16 plus 2, 5, 6. If you square it, it will be 256, and you can find the answer very easily. You can find also theta, tan inverse 8t by ac. ये एंगल भी निकाल सकते हैं आप. अगर आपको ये एंगल निकालना है तो tan inverse AT by AC कर दो. अगर आपको ये एंगल निकालना है tan inverse AC by AT कर दो. वो भी इजी है, आप कर सकते हैं. इसको आप कर लो और थोड़ा सा एक दो बार जब आप करेंगे तो आपको पता चलेगा where we should use this formula, where we should use integration technique, right? जब ये अल्फा फंक्शन ऑफ टाइम है तो ये फॉर्मूला इस्तेमाल मत करो. अगर कांस्टेंट है तब जाकर ये फॉर्मूला इस्तेमाल कर सकते. हो गया? Okay. Let me go to another example. Okay, let it be fourth example. There is a object connected to a string and you whirl it around your head like this in a circle. You are whirling it with a speed of v. Mass is m. Find tension. How much force you need towards the center? mv square by l. L is the length. Who provides that force?
Tension.
So I will write F is equal to ma. What is F? Real agent. T. Only T. What is ma?
Yes.
mv square by
MV square by
answer.
L.
हो गया ये. Fifth application. It's a rod, let me suppose, and it has a string mass connected to this string and there's another mass connected to this string. This mass is 1 kg, this mass is 2 kg, right? What is tension on this? Let me suppose tension always pulls, so what's the direction of the tension? Tension direction will be T1 like this. Sorry. T1 will be the direction like this. What is tension here on this object? It has string connected from both the sides. So it will be tension T2 here. Anybody can tell me what's tension here? Yes?
T1.
Certainly T1 because it is the same string and string is considered to be massless. If the string is massless, then tension along the string is the same. But here the direction is this and here the direction is opposite, right? And now what you do is that you whirl this whole configuration around this rod with omega. ऐसे इसको घुमाते हैं आप. इसको इस रॉड के इर्द गिर्द घुमाते हो दोनों मासेस को. और ये 1 मीटर का लेंथ है यहां से यहां तक और ये 2 मीटर है. ठीक. और ये भी 1 मीटर है. क्वेश्चन इज व्हाट इज T1 टेंशन कितना है और T2 टेंशन कितना है. ये हमारा क्वेश्चन है. दोनों को निकालना पड़ेगा. You have to give me the answer. अच्छा चलो मैं ही दिखाता हूं, लास्ट में आपको असाइनमेंट देता हूं मैं. चलो देखता हूं who will understand. So देखिए मैं क्या करता हूं, क्योंकि यहां में सिर्फ एक टेंशन की बात है ना T1 की. So first of all we will try to find this T1. यहाँ तो दो टेंशन्स है, इसलिए हम पहले ये चीज करते हैं. तो it moves in a circle, this one moves in a circle, this mass around this rod. So what is the equation that I will write? Who are the agents? Who are the agents? Tension is the agent. Good. That means m r omega square. M is this m. What is r? Okay, r omega square. This is the centripetal force, right? This is the centripetal force needed to move this object in a circle of radius, okay, 2 meters or radius r. I will write equation for this. Who provides this? Who provides this force to move this object in a circle? Because it's a requirement. That requirement has to be provided by a real agent. Who is the real agent? Yes?
T1.
That is good. T1 is the real agent.
T1.
Yes, that is right. So this centripetal force is provided by T1. Okay. Now, this m is 2, r is 2 meters, omega is given to be 2 radians per second, that is 4, is equal to T1. So T1 is equal to 16 newtons. तो पहले आंसर हो गया ये पहले का. अच्छा, अब जरा देखो, ये ऑब्जेक्ट भी सर्कल में घूमता है ऐसे, ये भी सर्कल में घूमता है. ये इसके लिए क्या लिखूं? सेंट्रीपिटल फोर्सेस mr omega square is provided by whom? Yes?
T1 minus T2.
The net force.
T1 minus T2.
Obviously. Yes, that's you are right. T2 minus T1. The difference of these two tensions provide the centripetal force towards the center to make it move in a circle. Because to make a body to move in a circle, you always need a force mv square by r towards the center. Yeah, m r omega square. So it is T2 minus T1. Right? So it is m is 1 kg, r is 1 meter here. You see, r is 1 meter. And omega square is 4 is equal to T2 minus 16. Right? So T2 is equal to 4, left side में 16 add हो जाएगा, 20 Newton. और देख लो, ये carefully देखो, T2 is greater than T1. That is the answer. It's a good question. It has been asked in the previous exams. Okay, let me go to the sixth example, sixth application. Let me ask you a few simple things. It is a pendulum. It's oscillating like this. Oh, sorry, it is very difficult to draw the sorry again. Okay, object is here and string is this length there, and here the object may move with 10 meters per second, right? And it moves and goes over here and also moves in the upward direction with velocity I don't know, let me suppose. And here it is the angle of 37. Object moves in a circular arc back and forth about the point O. It's the pendulum type and the object oscillates. The mass is m. Now the first thing that what is the question? The question is, what is the tangential acceleration when it reaches point P? Here it may be the point P. What is the tangential acceleration? At point P. That is the question. If I ask you to write equation here, possibly you'll say, yes, it is mg, it is tension T, and it is mv square by r is equal to T minus mg. This is the equation, this is the requirement, these are the agents which provide the force. And you will write m is m and v square is 10 square by r, possibly this may be given, it is T minus mg. Many things will be given and you will get the answer. But I want tangential acceleration here at this point. How to do it? You concentrate here. Mg is downwards, is it? Mg force is vertically downwards. What is this force? What is this angle?
Mg cos.
No, what is this angle?
37.
37. Okay. Can anybody tell me what is this component of this force along this direction? That's mg cos 37. Can anybody tell me what is this force in this direction, to tangential to the path? This is a path and this force is, this component is tangential to the path. Can you tell me what is this force?
Mg sin.
Mg sin theta. Sine 37. Yes. Now, can you guess what should be the tangential acceleration? The particle is trying to move ahead with velocity v, but there is some backward force. When I put into two components, the backward force, this is a radial force. It acts along the radius, this force mg cos theta, and this is tangential force backward. Can you tell me what is the tangential acceleration? Yes. What is the tangential acceleration? Okay. Okay, I will tell you something. F is equal to ma, right? What is A? F by m. अगर मैं इस A को T कर दूं तो इस F को क्या करूं? T.
T.
फिर से बताता हूं. F is equal to ma, right? A is equal to F by m. अगर मैं इस A को T कर दूं, यहां पर राइट साइड को T किसको कर दूं? फोर्स को T करोगे ना, कि M को T करोगे, टेंजेंशियल मास. No, you don't do that. So this tangential acceleration is nothing but tangential force, that is mg sine 37 by m. This cancels and this is the answer, g sine 37. But the only backward tangential force is this. So what's the tangential acceleration? It should be straight away tangential force by mass. It is this tangential acceleration which decreases this speed. I have already told you tangential acceleration is rate of change of speed. When there's a backward tangential force along the radius, along this path, along this arc, the backward tangential acceleration is this. That is responsible for reducing this speed. And finally, it will stop and come back. Is that right?
Yes.
Is that right? Yes. Okay. Just mark it well, how to find tangential acceleration at any point. Find the tangential force, divide by the mass, and find the tangential acceleration. It's as simple as that. And if I ask you what is the alpha, angular acceleration, that is just I ask a question. See, tangential acceleration is equal to alpha r. Here r is L.
R.
Alpha you can find if AT is given to be like this, and alpha can be. So angular acceleration at this point you can also find by this equation. You can mark it, you can just copy it, and we can go ahead. Seventh application. Here we have a pendulum, but we whirl it in a circle. It's a conical pendulum called as. It's a conical pendulum, means that you move it in a circle just beneath the fixed point. Can you imagine that? Can you imagine a mass is whirled in a circle beneath a point? It moves in a circle like this. Okay? I had to find for it a stability. It moves in a stable circle, and for that I had to find this. What is this theta? At a particular theta, it will continue to move in a circle. I had to find that theta, the conic angle, the cone angle. I had to find. See what I will do. Suppose this is L, and can anybody tell me what's the radius of the circle? But I just asked this question. This is L. This is L cos theta. This is L sin theta.
L sin theta.
If I ask you what is this from here to here, there's L cos component.
L cos.
This is hypotenuse, and this is a cos component of L, and this is sine component of L. Look at the positive sign that I am moving here and there. Okay, M is downwards. Tension is like this. If I draw a line here, this is also theta. Tension can be put into two parts, that is T cos theta, and this in this direction there's T sin theta. This is a center O. Now let me ask you a question. How much force you need towards this center, towards this point?
T sin theta plus L sin theta.
नहीं इस डायरेक्शन में आपको क्या फोर्स चाहिए so that a particle moves in a circle?
mv square by r.
mv square by r is nothing but L sin theta.
Yes.
mv square by r is the radius of the circle, but that is L sin theta. That is given by T sin theta.
T sin.
And for the stability of the object to be continuously moving in a circle, not going down, not going up, so what should you write?
T cos theta is equal to mg.
mg is equal to T cos theta. ठीक. If I divide them, what I am getting? M gets cancelled. Okay?
Yes.
V square by LG sin theta
V square by LG sin theta
is equal to tan theta.
Sin theta by cos theta, keep it like that. Because I have to find theta. I will tell you, explain you how I will find theta in this case. Right? That I will tell you in a few moments. Now, it is V square by LG is equal to sin square theta by cos theta. No? Put it here.
Yes, sir.
It is 1 minus cos square theta by cos theta.
Yes, sir.
Do you agree with me?
Yes, sir.
Good, good. Have patience, have patience, have patience. Sometimes you lose patience and try to run away from the lecture. Okay. Now, let me write an equation. I will see whether you understand or not. 1 minus cos theta square theta is equal to V square by LG cos theta is equal, implies cos square theta minus plus V square by LG cos theta minus 1 is equal to 0. Do you understand this when I write this equation?
Yes.
Cos square to the right, positive.
Yes.
1 to the right. Don't make noise. Now it's the quadratic in cos square theta. So what's cos theta? Because it is quadratic. It is that quadratic rule minus V square
Minus
LG
square by L.
plus minus root of V square by LG whole square
Square.
B square plus 4, 1 into 1, that's 4, divide by 2. Is that right?
Yes.
That is the answer. You find theta, find cos theta, you can find theta. But delete this negative sign. Take a positive sign of this, because both the negatives will make theta more than 90, which is not possible because it is oscillating like this. Theta cannot be more than 90. It cannot be like this oscillating. It can be like this, 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 but it can be like this. So be careful that you don't need to have negative sign here. You need positive sign. So negative sign here, positive sign here will somehow make it positive, and theta will be less than 90. Okay?
Yes, sir.
It is all done. Now one more example. It's a eighth point. It's a disk here. It's a disk, and this disk rotates with omega, and there's an object here on the disk. And when disk rotates with omega angular velocity, this object also moves in a circle on the disk with radius r. We have to find what is maximum omega max. If you increase this omega and rotate it faster and faster and faster, and there's a possibility that this object will skid away. It will move away. It will move away from the disk. We have to find omega max above which this object will skid. I mean, less than this omega, it will remain moving in a circle. More than this omega max, it will skid off. So how can you solve this question? Now see, how much force I need towards the center for this? M omega square is equal to, who provides that force? Is there any object? Is there any string? Is there any external agent which keeps it moving in a circle?
No, sir.
No, there's no obvious agent from outside to keep it moving in a circle. String होता तो हम सोचते कि ये टेंशन है, लेकिन string तो है नहीं. It is just on the disk. लेकिन imagine करो, अगर डिस्क और ऑब्जेक्ट जो है, सपोज ये डिस्क फ्रिक्शनलेस है और ऑब्जेक्ट तो ये रिसीड करेगा, स्लिप करेगा. इसका मतलब it is the frictional force which keeps it moving in a circle.
Yes, sir.
Try to understand. जो रफनेस है ना, इस डिस्क और इसके दरमियान जो रफनेस है, that keeps it moving. तो maximum frictional force is mu mg. तो ये जो centripetal force है, ये इस फोर्स से कम होना चाहिए. It must be less than this or equal to. अगर ये फ्रिक्शन, ये centripetal force इससे ज्यादा है, इसका मतलब even the maximum frictional force cannot provide this force. So the centripetal force must be less than this frictional force, right? Maximum frictional force. तो मतलब साफ है, अगर ये centripetal force इससे भी ज्यादा है, then frictional force cannot sustain it. It will skid off. Right? So m gets cancelled. So omega square is less than equal to mu g by r. तो इसका मैक्सिमम वैल्यू क्या है? इक्वल टी पर होगा ना, या तो लेस देन है या इक्वल टू. तो मैक्सिमम वैल्यू क्या हुआ?
Equality.
इक्वलिटी तो होगा या लेस. इज दैट राइट? सो रूट ऑफ म्यू जी बाय आर. मैंने फ्रिक्शनल फोर्स पढ़ाया नहीं, इसलिए यहाँ पर मैं आपको ज्यादा नहीं बता सकता हूँ, लेकिन आप याद रख सकते हो कि सेंट्रीफ्यूगल फोर्स मस्ट बी मैच्ड बाय द फ्रिक्शनल फोर्स. दिस इज ऑल डन. ओके, नाउ लेट मी गो टू द 9th एग्जांपल. 9th, मेरे पास एक रॉड समझो, it has a 2 strings like this and like this, and mass is attached to this, mass m, and this rod I rotate with omega. This rod I rotate with omega. When I rotate this omega, this mass also moves in a circle. It moves in a circle. It moves in a circle of this radius. Like it is length L, string length, it is string length L. And let me suppose this is theta. And this is also theta because string length is the same. ठीक? What should be omega? Minimum value of omega. So that this string, second string, lower string, so that lower string just dot. Don't make a noise. Don't make noise. Boys, don't make noise. Okay. ये omega don't make noise, and please switch off your audios. Okay. Now the point is omega minimum, so that this is just dot. What do we mean by just dot? I will explain you. Suppose it is tension T1, it is tension T2. Just dot means, or just slag or just dot means this T2 is 0. There is no tension in this string. ये ओमेगा कितना होना चाहिए ताकि इस स्ट्रिंग में कोई टेंशन नहीं बचता है? That is our question. You whirl this around and this mass rotates with these two strings connected. It moves. अच्छा मैं दिखाता हूँ. It moves in like this, like this, like this, like this, like this. Moves in a circle like this. It moves in a circle like this, and we have to find what should be the omega so that this second string is just dot. Just dot means this T2 is 0. Otherwise, there will be, if it moves with greater angular velocity, it will get stretched. I mean, the tension T2 will be developed. Okay, let me try to write down the general equation so that you understand. एक लाइन डाल दीजिए ऐसे. तो अगर ये थीटा है तो ये भी थीटा है और ये भी थीटा है. मुझे बताइए how much force I need in this direction so that this object moves in a circle of radius. Okay, it is L cos here, it is L sin theta. So in how much radius it should move in a circle? L sin theta. So what is the centripetal force? M L sin theta, that is R omega square. Who provides that force? Can anybody tell me here? This is T1 cos theta. This is T1 sin theta. And this T2 cos theta. And this is T2 sin theta. So ML sin theta omega square, that is the centripetal force. Who provides this force? Who provides this force? Can anybody tell me? Yes, I will tell you. इस टेंशन का ये वाला कंपोनेंट और इस टेंशन का ये वाला कंपोनेंट, that is T1 sin theta plus T2 sin theta. इस टेंशन का ये वाला कंपोनेंट प्रोवाइड करता है और इस टेंशन का ये वाला कंपोनेंट प्रोवाइड करता है this centripetal force to make the body move in a circle of this radius. Is that right? Now, can you write any equation for this and this? What should I write? T1 cos theta is equal to, okay, anybody can tell me that? Can anybody tell me that? Okay, I will tell you. It is T1 cos theta, but downward force is T2 cos theta here. But downward force is also mg. Don't forget that. So how many forces are in the downward direction? T2 cos theta plus mg. ठीक? Okay, now see. But this equation you have to understand. The centripetal force provided by the two components of the tension T1 and T2. And T1 cos has upward force. It should be balanced by the two downward forces. That is T2 cos downwards, but plus mg also downwards. Right? Now see what I will do. Now put T2 is equal to 0. What I will get? First equation reduced to equation 1 and equation 2. Equation 1 reduces to what? M L sin theta omega square is equal to T1 sin theta. And T1 cos theta is equal to simply mg if T2 is 0. Right? So these are the two equations. Now I will divide them. डिवाइड ये T1 मुझे यहां रखना चाहिए ताकि मैं डिवाइड कर लेता अच्छी तरह से. वैसे भी यहां ये खत्म हो जाएगा साइन और साइन. सो ऊपर वाला इक्वेशन ये जो बनेगा, इट इज ML ओमेगा स्क्वायर इज इक्वल टू T1 एंड T1 cos थीटा इज इक्वल टू mg. राइट? अब किसी तरीके से भी कर लो यार, ये T1 सब्स्टिट्यूट यहां कर लो या डिवाइड कर लो, जो मर्जी. ML ओमेगा स्क्वायर इज इक्वल T1 का वैल्यू mg बाई cos थीटा, mg बाई इस T1 का वैल्यू यहां भेज दिया तो m गेट्स कैंसल्ड. ओमेगा स्क्वायर इज इक्वल टू g बाई L cos थीटा, तो ओमेगा only omega is equal to root of g by L cos theta. That is the answer for omega minimum. इससे ज्यादा होगा तो टेंशन डेवलप होना शुरू हो जाएगा. T2 T2 टेंशन डेवलप होना शुरू हो जाएगा. This is all done. Okay. Now let me go to one more point, that is, अगर आपके suppose everybody knows Earth revolves around the sun. It is Earth revolving around the sun. Let me suppose of radius r. It moves with the speed v. How much force you need towards the center of the sun? Which is mass m, small mass m. How much force you need if Earth moves in a circle? Although it moves in an ellipse, but let's suppose here it moves in a circle. How much force we need for the Earth to move in a circle of radius r? M v square by r. Who provides that force? Who provides that force? Yes, that force is provided by the gravitational force between the Earth and the sun, that is G m small m by r square. In gravitation, you get so many things from this base equation, but the base equation is basic equation for a circular motion. The centripetal force provided by the gravitational force. Okay, now in case of hydrogen atom also, in case of hydrogen atom, it is proton, it is electron revolving around the nucleus with a speed v and a radius of r. So can you tell me how much force you need towards the center for an electron to move in a circle of radius r? It is charge is e and proton charge is also e. But there's attraction between electron and proton towards the center. Can you tell me how much force you need for an electron to move in a circle of radius r? Again, that is m v square by r. Who provides that force? Electrostatic force. Electrostatic force of attraction between electron and proton. How much is the electrostatic force between electron and proton? That's 1 by 4 pi epsilon naught E square by R square. 11th class students don't know this equation. 12th class students may be knowing this equation because they know the electrostatic force between the two charges. So these are the basic things that you need to understand. You just do it again at your own places, and tomorrow I will give solve objectives and problems from NCERT books and ICVAMA. That will be tomorrow's lecture. Again, that lecture will be for NEET exams. Okay, let me now stop the lecture. This is आज के लिए काफ़ी है. इंशाल्लाह कल हम फिर से इसको आगे ले जाएंगे. Okay.